FORA.tv. The world is thinking.
You are not born with a finite number of brain cells that die off, and by the time you're done, you have fewer. In fact, about 10 years ago, a scientist in La Jolla at the Salk Institute, a guy named Fred Gage, determined that all through the life cycle, you are producing new neurons. That's pretty amazing. And what happens as you get older, and one of the reasons why, one of the thoughts is that one of the reasons why your memory isn't quite as good as you get older is because the production of new brain cells slows down. So it's not like you stop making new brain cells. It's just that the process slows down. A lot of things slow down in your brain as you get older. And this is one of the things. So if neurogenesis is slowing down in an older brain, the question is, what can you do to bring it back up? Can you do anything? And the other kind of remarkable finding is that there are only two places in the brain where these new neurons are being produced. One of them is a place called the olfactory bulb, which is part of your smell facility. But the other one is in that place in your brain that I told you goes kind of kaflooey when you have normal memory loss, the dentate gyrus. So that's the place where new neurons are being made. That's the place where, as you get older, there seems to be an impairment. And so it's pretty remarkable because if you think about it, if you can then kind of produce new neurons in that part of your brain, maybe you've now got an intervention that's going to be helpful. So that was the thinking in the experiment. And the first experiment that sort of tried to figure this out, they did with mice. And so they put the mice in the mice scanner. There is a mice scanner. It's really kind of cute. So they put the mice and they anesthetize them. The mice are fine. And they even put like little earmuffs on the mice so that the magnet doesn't make them crazy because it's very loud in the scanner. So they put the mice in the scanner and they got a sense of what the cerebral blood volume was in their brain, so how much blood was in there. Then they put the mice, so they had a control group who just lived in their cage, they didn't have a wheel. And then they put the mice in with a wheel, an exercise wheel. And they had a pedometer on the wheel. And so they could tell like how many kilometers these mice were running. And they were running kilometers, in the hundreds of kilometers, which was pretty astounding. And so at the end of a certain amount of time, they took the mice and they put them back in the scanner. And as you can imagine, the mice who had done nothing looked exactly the same as they had before. The mice that exercised they had more cerebral blood volume, which is a proxy for more neurons, because there'd be more cells. So the exercising mice had more cells. And then, it gets better, they gave them, the exercising mice had more, the ones that exercised the most had the most increase in brain cells. So then the question was, okay, great, but can they remember anything? Are they going to remember to pick up the milk on the way home from whenever? So they gave them a memory test. The memory test for mice is pretty interesting. Mice don't like water, so they put them in water. And there's a little platform in the water and it's submerged, and they first put the mouse on the platform, and then the mouse has to remember where the platform is. So the non-exercising mice were not very good at this task, and sadly. The exercising mice were much better. They learned quicker where the platform was, and the ones that exercised the most remembered even quicker. So this was an interesting finding, and it was pretty great, but it was for mice. So then they decided they would do this for people. And again, this was done at Columbia, and I was there, and it was really cool. They took sedentary people, they gave them an exercise regimen of 12 weeks for like 4 days a week for 45 minutes. They scanned them before, they scanned them after, they gave a memory test before, they gave a memory test after, and lo and behold, the results of the tests on the people looked exactly like the results of the test for the mice. And the conclusion of that is that if you exercise, you are actually, aerobically, you are actually putting more, increasing the production of neurons in your brain. So you're putting more brain cells into your brain than you would be doing if you were doing nothing. And for me, that's an incredibly hopeful conclusion, because it means that you've now got an intervention that does something that if I told you I had a drug that could improve your memory, that could create new brain cells, that could connect those brain cells and give you more synapses and therefore make you brighter, if I said I had that drug, you would say, I want it, and I would say, how much are you willing to pay me? And you would say, a lot. And I'm telling you that there's something that's out there that does all of those things, and there is no copay. So, take that for, take it for what it's worth, but I think it's worth quite a lot.